For the first time in years, SpaceX is finally pulling back the curtain on its moon landing mission, a project that could define the next era of human spaceflight or expose cracks in the entire Artemis program. Behind the tests, politics, and deadlines, something much bigger is unfolding. So what's really happening with SpaceX's moon landing? And why are NASA officials suddenly sounding the alarm? It all begins, not with rockets or engineering, but with politics. On October 20th, acting NASA Administrator Sean Duffy made headlines when he publicly called out SpaceX, threatening to reconsider their multi-billion-dollar moon landing contract during a live interview on CNBC's Squawk Box. His message was blunt. "I love SpaceX. It's an amazing company. The problem is they're behind. They've pushed their timelines out, and we're in a race against China." He wasn't entirely wrong. Both NASA and SpaceX have fallen behind schedule in the race to return humans to the moon. But the reality is far more complicated than what Duffy implied. The Artemis Program, NASA's ambitious effort to land astronauts on the lunar surface once again, has been plagued by delays for over a decade. Its core systems, the SLS rocket and the Orion spacecraft built by Boeing and Lockheed Martin, took more than 11 years to get off the ground. The first uncrewed mission, Artemis I, finally launched in late 2022 after countless setbacks. The second mission, Artemis II, which will send astronauts around the moon, has already slipped from 2024 to a tentative date in 2026. Meanwhile, SpaceX has been racing ahead with its own revolutionary vehicle, the Starship, a fully reusable super heavy launch system designed to carry humans not just to the moon, but eventually to Mars. In just 5 years, SpaceX has conducted over 20 test flights, achieving multiple successful launches and landings of the most powerful rocket ever built. So when Duffy accused SpaceX of falling behind, it struck many as ironic NASA's own timelines have been stretched thin for years. Yet his statement raised the stakes dramatically and sparked a public feud with Elon Musk himself. Within hours, Musk fired back on his platform X, calling Duffy a dangerously stupid, unqualified dummy trying to kill NASA. Harsh words, but not entirely surprising. The tension between government bureaucracy and private innovation has always been volatile, and this time it exploded into full view. Behind the scenes, President Trump, who had re-entered the political spotlight, was reportedly growing frustrated with NASA's slow pace. According to insiders, he wanted a moon landing within his current term. No matter the cost, Duffy's comments were a reflection of that pressure, a warning shot to SpaceX, and perhaps a political maneuver to invite competitors like Blue Origin back into the conversation. But if the goal was to intimidate SpaceX, it didn't work. Instead, the company responded in the best way they know how. With data, progress, and an audacious promise, Elon Musk wrote, "Starship will end up doing the whole moon mission. Mark my words." And with that single post, SpaceX shifted the tone of the entire race. Because if Musk was serious, it wouldn't just change how we reach the moon. It could change who controls humanity's path beyond it. When the political dust began to settle, SpaceX did something unexpected. They broke their silence. In a rare public update, the company revealed the true scale of their progress on the Starship program, and for the first time, confirmed that they had been developing 2 separate versions of the vehicle all along. The first path, the one we've seen in countless test flights from Starbase, is what SpaceX calls the core Starship system. This is the version built for Mars, a fully reusable interplanetary transport system capable of carrying 100 tons of cargo across the solar system. Every spectacular test flight, every explosion, every successful landing, all of it has been part of that long-term vision. It's the spacecraft designed to make humanity multiplanetary. But then there's Path 2, a much quieter, more secretive project unfolding behind the scenes. This is the Human Landing System, or HLS, the lunar variant of Starship. Unlike the Mars-bound version, HLS is designed specifically to ferry astronauts from lunar orbit down to the moon's surface and back again. It doesn't need heat shields or wings. It will never re-enter Earth's atmosphere. Instead, it's built for one purpose: to land humans on the moon. This is where the NASA contract comes into play. When SpaceX was awarded $2.9 billion in 2021 to build the HLS, the deal wasn't just about money. It was about trust NASA agreed to pay only after each milestone was completed, meaning SpaceX had to prove its progress step by step. And according to the company's latest update, 49 milestones have already been reached, covering everything from engine development and communications testing to full-scale mock-ups of the crew cabin deep inside SpaceX facilities. Engineers have been testing life support systems, temperature regulation, and humidity control inside a full-scale model of the lunar Starship's interior. This is where astronauts will live and work on the moon. And SpaceX has already conducted multi-person simulations inside the habitat. Meanwhile, another prototype has been used for drop testing, literally lifting and dropping a full-scale model onto simulated lunar soil to analyze how the landing legs interact with the ground. That's not all. SpaceX has also been testing an airlock and elevator system in collaboration with Axiom Space, the company building NASA's new lunar suits. Astronauts have been rehearsing how they'll exit the spacecraft, descend to the surface, and move under full pressure long before the real mission ever launches. Then there's the Fuel Depot, a massive orbital refueling station that will allow Starship to top off its tanks before heading toward the moon. This system is crucial. Without it, the mission isn't possible. SpaceX has already begun small-scale cryogenic fuel transfer tests, simulating how liquid methane and liquid oxygen could move between spacecraft in the freezing vacuum of space. When they attempt this full scale for the first time, it will be one of the most complex maneuvers ever attempted in human spaceflight. Finally, there's the software and guidance system, the digital brain that will autonomously find a safe landing site on the moon and bring Starship down gently onto the surface. That technology is being tested with the same flight computers, sensors, and cameras that will be used in the real mission. Piece by piece, SpaceX is assembling the blueprint for a new era in exploration, a self-funded Mars ship evolving into a government-backed moonlander. Two paths converging on a single goal, returning humanity to the lunar surface. And as Elon Musk put it, this isn't just about fulfilling a contract, it's about proving that one company can do what once required an entire nation. While the world focused on rocket launches and fiery explosions in Texas, a different kind of progress was unfolding quietly behind closed doors. At facilities across the United States, SpaceX engineers have been working around the clock on a series of classified tests, not to impress the public, but to prove that Starship can actually survive the moon. The first major breakthrough came with the lunar landing leg tests. Using a full-scale model of the HLS Starship, SpaceX simulated touchdowns on artificial lunar soil, an environment designed to mimic the moon's loose, powdery regolith. Sensors recorded every vibration, every shock wave, every fragment of dust. The results? A new reinforced landing system capable of absorbing impacts without destabilizing the ship, even on uneven terrain. Then came the airlock and elevator trials, built in partnership with Axiom Space. This was more than a mechanical test. It was a human one. Astronauts wearing the new lunar suits practiced stepping into the elevator, cycling through the airlock, and descending onto simulated moon terrain. Every movement was timed, measured, and refined, from hand placement to suit pressure, to ensure no wasted motion once they're standing on the real lunar surface. But perhaps the most crucial tests are happening in extreme environments few ever see. SpaceX has been conducting Raptor engine cold starts, chilling the powerful methane engines to cryogenic temperatures and reigniting them after hours of freezing exposure. These tests simulate what would happen after days or weeks of inactivity in deep space, when the engines must restart flawlessly to bring astronauts home. They've also begun micrometeoroid and debris impact testing, bombarding panels of Starship stainless steel with high-speed projectiles under extreme temperature swings. These trials ensure that even the smallest space rock or temperature shift won't compromise the hull's integrity during flight or lunar operations. And beneath all the hardware lies the most vital component of all, the autonomous landing software. It's being trained with real sensor data to identify flat surfaces, avoid craters, and guide Starship to a perfect landing without a human touching the controls. Every one of these developments brings SpaceX closer to the impossible, because while most of the world sees rockets exploding and headlines arguing over delays, what they don't see are the hundreds of silent tests proving that Starship isn't just a dream, it's a machine built for the moon and beyond. After months of silence and speculation, SpaceX finally unveiled what may be the most ambitious idea in the history of modern spaceflight: a simplified lunar mission architecture that could render NASA's decades-long approach obsolete. In their official update, SpaceX stated, "Starship continues to be the fastest path to returning humans to the surface of the moon, and a core enabler of the Artemis Program's goal to establish a sustainable presence. We have shared ideas on how to simplify the mission and believe this approach will result in a faster return while improving crew safety." At first glance, the statement seemed ordinary, a corporate progress note, but within it was a revolutionary proposal. SpaceX was no longer just building a lander to assist NASA's plan. They were proposing a system that could replace it entirely. Instead of relying on NASA's SLS rocket and Orion capsule to transport astronauts into lunar orbit, SpaceX was suggesting that Starship alone could handle the entire journey, from Earth's surface to the moon and back again. One vehicle, one architecture, one company. For decades, NASA's missions have required a complex choreography of multiple spacecraft, rockets, and contractors working in fragile coordination. The Artemis program follows that same pattern, launching astronauts aboard Orion on the SLS, docking with Starship in lunar orbit, transferring crew, then reversing the entire process to return home. Every stage adds risk, time, and cost, but Musk's vision eliminates that. His proposal turns Starship into a self-contained lunar transport system capable of handling the full round trip with only minimal external support. It's an idea that redefines the word simplified. However, there's a catch. The lunar Starship, as currently designed, cannot re-enter Earth's atmosphere. It lacks heat shields and aerodynamic surfaces needed to survive the fiery descent. But SpaceX already has a workaround: the Dragon capsule, which has safely returned astronauts from orbit multiple times. The two vehicles could dock in space, allowing astronauts to transfer from Starship to Dragon for a safe re-entry to Earth. Alternatively, a Dragon capsule could launch first, meet Starship in orbit, and carry the crew for the outbound journey. A fully reusable modular system that cuts NASA's cost and complexity in half. This, Musk argued, is what simplified mission architecture truly means, replacing an entire national program with one privately engineered vehicle. Behind the scenes, this bold proposal sent shockwaves through NASA and the political establishment. Some saw it as arrogance, others as genius, because if SpaceX could actually pull it off, it wouldn't just make them a contractor, it would make them the gateway to the moon. And with a new NASA administrator, Jared Isaacman, stepping in, a billionaire pilot, astronaut, and longtime Musk ally, the timing couldn't have been better. Isaacman's appointment marked a turning point. For the first time, both NASA leadership and SpaceX were aligned in vision and ambition. The bureaucracy that had slowed progress for years was suddenly clearing. But make no mistake, this is still a race against time. President Trump has publicly stated his desire to see boots on the moon before the end of his term, and the clock is ticking. The revised schedule now targets 2026, but even that may be optimistic. Hardware testing, propellant transfer trials, and full-scale orbital demonstrations still lie ahead. Each one carries immense risk, and none guarantee success. Still, if there's one company that thrives under impossible deadlines, it's SpaceX. They've built rockets faster than Boeing can assemble a single launch tower. They've achieved reusability when the industry said it couldn't be done. And now, they're attempting to turn one of humanity's most complicated engineering challenges into a streamlined, privately managed reality. For Musk, this isn't just about fulfilling a contract. It's about proving a point that private innovation can outpace government bureaucracy, and that the path to the stars no longer depends on politics, but on engineering. If SpaceX succeeds, it won't just mark the return of humans to the moon, it will signal the dawn of a new era, one where exploration is no longer the domain of nations, but of visionaries, where the word impossible is just another test to be passed. And this time, humanity's next step on the moon might be taken not by a government program, but by a company that refuses to wait for permission. The race for the moon is no longer a competition between superpowers. It's a race between visions. On one side, a government program built on tradition, politics, and legacy. On the other, a private company fueled by ambition, speed, and risk. And, somewhere in between, the fate of humanity's next great leap. NASA's Artemis program remains a cornerstone of international cooperation, a promise to establish a permanent human presence on the moon. It's a vision decades in the making, supported by thousands of engineers across the world. But the reality is harsh. Bureaucracy moves slowly, and the cost of innovation grows with every passing year. SpaceX, however, thrives on acceleration. In less than 2 decades, they've transformed from a struggling startup into the most advanced launch provider on Earth. Their rockets now deliver satellites, astronauts, and cargo to orbit routinely. And with the Starship program, they've set their sights on something bigger, turning humanity into a multi-planetary species. But before Mars, there is still the moon. And what happens in the next few years will determine who writes the next chapter of space exploration. If SpaceX's vision succeeds, it will fundamentally change the way we explore a single reusable spacecraft, refueled in orbit, capable of landing anywhere, not just on the moon, but on Mars, Titan, or Europa. It's a system designed for evolution, a machine that can adapt to any world. Yet even the most revolutionary designs face one unyielding truth: space doesn't forgive mistakes. The smallest miscalculation, a frozen valve, a missed signal, all can turn triumph into tragedy. And with human lives at stake, every launch carries a weight that technology alone cannot bear. Still, humanity has never advanced by waiting for certainty. The Apollo program was born from fear and competition, yet it united the world in awe. Now, more than 50 years later, we stand on the edge of a new beginning. The next footprints on the moon won't just belong to astronauts. They'll belong to an idea that the stars are no longer out of reach. The future of the moon race will not be decided by who gets there first, but by who dares to stay. And if SpaceX can deliver on its promise, a sustainable, reusable, and independent path to the lunar surface, then the next flag planted on that gray horizon might not bear a nation's insignia, but the mark of a company that refused to follow the rules of the past. Because innovation isn't about competition, it's about conviction. And right now, SpaceX is betting everything on the belief that humanity's destiny is out there, waiting. If you've enjoyed this exploration into SpaceX's moon landing, don't forget to like this video, subscribe, and turn on notifications so you don't miss what's coming next. Every week, we uncover the hidden stories shaping the future of space exploration. From the depths of the solar system to the frontiers of human ambition,